Hi, I'm Torben Jansen from thoughtsonjava.org, and in today's video I will show you how to integrate Hibernate and jOOQ. In my opinion, a match made in heaven. JPA and Hibernate make the implementation of simple CRUD operations extremely easy and efficient. But they lack support for complex queries. You can use JPQL and the criteria API to define queries of mediocre complexity. If you need more, you need to write a native SQL query as a plain, untyped string and handle the finite details of different SQL dialects yourself. jOOQ, on the other hand, provides a powerful DSL to create SQL queries in a comfortable and type-safe way. So why not use the two of them together to get the best of both options? As I will show you in this video, Hibernate and jOOQ work very well together. With a little bit of preparation, you can use Hibernate's entities to implement your write operations and to generate jOOQ's metamodel classes. You can then use jOOQ's DSL to build fully featured SQL queries in a type-safe way and execute them as native queries within the context of your current persistence context. For the remainder of this video, I expect that you are familiar with JPA and Hibernate, know how to define your domain model, and how to implement standard CRUD operations. If that's not the case, I recommend you take a look at my Getting Started with Hibernate guide before you continue watching this video. And if you like this video, please make sure to subscribe to my channel and to hit the bell icon. I'm uploading new videos every Tuesday and Thursday, and you don't want to miss any of them, do you? Before you can start using jOOQ and Hibernate in your application, we need to talk about the structure of your project. jOOQ provides a set of code generators which you can use to generate your jOOQ metamodel automatically. The JPA database generator is one of them. It generates jOOQ's classes based on your annotated entities. To make this work, your project needs to follow a certain structure. You need to reference a jar file with your entities as a dependency of the code generator. That's why I prefer a Maven project with the following three modules: entities, jOOQ, and business or persistence. The entities module is independent of all other modules. The code generator used in the jOOQ model depends on the entities defined in the entities module. And the business module depends on the two other modules. It uses entities and jOOQ's DSL to implement and execute your persistence code. Okay, let's check them out in the IDE. Let's take a look at the entities module first. It contains all entities used in the application. For this example, I prepared two simple entities. The author entity models a simple author with an ID, a first name, a last name, and a list of books as a many-to-many association. And the book entity models a book with an ID, a title, a publishing date, and a list of authors as a many-to-many association. Okay. Now let's get to the jOOQ module, in which you don't need to write any code. The only thing you need is a build configuration that triggers jOOQ's JPA database code generator. It uses Spring to find all annotated entities in your class path, creates database table for these entities in a local H2 database, and then generates the jOOQ metamodel classes for these tables. Here you can see the Maven build configuration that triggers the JPA database code generator for all entity classes in the org.thoughts.on.java package and generates classes to the org.thoughts.on.java.jOOQ package in the source main Java folder. As I explained in more details in my Getting Started with jOOQ video, the code generator creates a set of classes that provide type-safe access to all database tables and columns. I will show you in the business module how you can use them with jOOQ's DSL to create fully featured SQL queries in a type-safe way. So let's continue with the business module. After you defined your entities and generated your jOOQ classes, you can finally use them to implement your persistence code. The easiest way to do that is to use your entities and entity manager in the same way as you use them without integrating jOOQ. Here is a simple example that creates and persists a new author and a new book entity. As you can see, there's nothing special about this code. But the creation and execution of a query with jOOQ requires a few additional steps compared to the relatively simple approach described in the Getting Started with jOOQ video. In the first step, you need to instantiate the DSL context for your database dialect. In this example, I use the PostgreSQL 10 database, which uses the 9.5 dialect. The next step might be optional for your database, but in my case, I had to set the render name style to as is to avoid any issues with capitalized table and column names. And after that, you can build your query. Here I'm using a relatively simple example which selects the first name, last name and book title of all authors whose first name starts with Tor. The only interesting part of this code block is the call of the setBindParameterValues method. As I explained in the previous video of this series, jOOQ automatically creates bind parameters and sets their values. But if you use Hibernate to execute the SQL statement as a native query, you need to set the bind parameter values explicitly. That's what my setBindParameterValues method does. It extracts all bind parameters and their values from the jOOQ query and sets them on the Hibernate query. That's all you need to do to execute the jOOQ query as a native query within the current persistence context. The good thing about executing the SQL statement as a native query is that you can use all result set mapping features provided by JPA and Hibernate. So you can map your query result to managed entities based on your mapping annotations, or you can use an SQL result set mapping annotation to map it to entities, POJOs, or scalar values. For this example, I use this SQL result set mapping to map each record of the query result to a book author object with the attributes first name, last name, and title. To use this mapping with your query, you just need to provide the name of the SQL result set mapping as the second parameter to the createNativeQuery method. As you have seen, you can easily use Hibernate and jOOQ within the same application. This enables you to use the best parts of both worlds. JPA and Hibernate provide a very efficient and comfortable way to implement write operations. jOOQ's DSL enables you to build fully featured SQL queries in a type-safe way. If you structure your application so that you can define a class path dependency to your entity classes, jOOQ's code generator can create meta-model classes based on your entity mappings. That makes sure that your entity model and your jOOQ model stay in sync and enables you to use the DSL in a type-safe way. After you've defined your query with jOOQ, you can execute it as a native query with Hibernate and use Hibernate's mapping functionality to map the records to the result set. Okay, that's it for today. If you want to learn more about Hibernate, you should join the free Thoughts on Java library. It gives you free access to a lot of member-only content, like a cheat sheet for this video and an ebook about the Java 8 support in Hibernate 5. I'll add the link to it to the video description below. And if you liked today's video, please give it a thumbs up and subscribe below. Bye!